So far, we have learned about one container data type, a list. And lists are really common. They are really common with for loops. And they are great at storing ordered collection of items. But there is another really popular data type, container data type that has a totally different philosophy. It is much more about the relationship between items. And a dictionary is actually really similar to the physical dictionary or to your physical phone book. So in a dictionary, what do you do? Well, given a particular word, you look up the definition, or in a phone book, what do you do? Given someone's name, you look up their phone number. So this idea that you have a key and using a value, you look up the value is exactly the operation that dictionaries encapsulate. So dictionaries are a way to store key value relationships. They don't care about ordering, but they are really useful for this type of relationship. So let's take a look at dictionaries and what we might use them for. So first things first, let's create a dictionary. Let's say that we are going to track our friends' ice cream flavors. And then we are going to use curly braces. Curly braces are the bad signal for the dictionaries. So ice cream, and then we are going to need a series of key value pairs. So let's say that Alice really likes chocolate, and then maybe Bob really likes strawberry. And maybe Kara really likes mint chocolate chip. And what are we defining? Okay, so we are doing an assign, and we have a dictionary. We are creating a variable that points to a dictionary, and we know it's a dictionary because of the curly braces. And inside the curly braces, we have a comma separated set of key value pairs. In this case, the keys are the strings Alice and Bob and Kara. And Alice is the key that maps to the value chocolate. And Bob is the key that maps to the value strawberry. And Kara is the key that maps to the value mint chocolate chip. So, comma separate the key value pairs. And within a pair, it's the key and then a colon and then the value. So we press the return, we will create this dictionary. So what do we do with the dictionary? Well, the main operation is looking up values based on their keys. And this actually looks really similar to looking up items in the list. But instead of caring about indices, numerical indices, we look things up based on their keys. So for example, if I want to look up Alice's favorite ice cream flavor, I use the square bracket syntax, but the key inside. So given the key, Alice, what is the value? What is her favorite ice cream flavor? Or similarly, given Bob, what is his favorite flavor? What if we try to look up someone in this list, a dictionary that doesn't exist? You know, what is Eve's favorite ice cream flavor? Oh, so we got a traceback, we got a key error. Python is telling us that Eve is not a key in this dictionary. Fortunately, we can update dictionaries, and the syntax for this is going to be again look really similar to updating items in a list. We take the dictionary and we specify the key, and then we do an assignment specifying the value that we want. So maybe you likes go, I don't know, rum raisin. So after this key value addition to the dictionary, we check ice cream. We should see Eve there with her preference as well. Now, if you look carefully here, if we look up to where we defined ice cream, we see the order was Alice and then Bob and then Kara. And if you look at it down here, that's not the order that we see anymore. What's going on here? Well, I was totally serious when I said that dictionaries do not care about order. And in fact, Python doesn't guarantee an order for the way that it displays the dictionaries. It might move things around to optimize the underlying storage. But we don't have to worry about it because we don't use dictionaries when we care about the order. So the whole things have to be the key value relationships. Another thing that's kind of like this is that you can check for containment. You can check if the key is in a dictionary. So we actually could have checked if E was there before we tried to pull out her preference. We could have said, is E in ice cream? And now she is, right? An important detail about dictionaries is that keys have to be unique. So, let's say that actually um, I have two friends named Bob. I have Bob 1 and Bob 2. And I said, okay, well, to add Bob number 2's ice cream flavor to this dictionary. So I would say, okay, well, Bob number 2 really likes vanilla. What happens here? Well, we execute this line of code, and if we check ice cream, we have not, in fact, added Bob number 2. We actually replaced Bob number 1's preference. So keys have to be unique. Values don't need to be. If Kara decides that actually she's on the vanilla train too, that's totally fine. We can say ice cream Kara equals vanilla. And so now Kara and Bob both like vanilla. That's fine. But keys have to be unique. All right. There are a couple of more details about dictionaries. So one question is, how do we create an empty dictionary? Given what we know, we should be able to, let's say, create a dictionary of phone numbers. If it is comma separated set of key value pairs and there are no key value pairs, it should just be open curly brace, close curly brace. How do we check the type of dictionary, or how do we check the type to see if it is a dictionary? We would use the type function from before. We are going to use dictionaries a lot in this series. So dictionaries are all about storing key value relationships. They don't care about orderings, but they are a very useful container data type for this type of relationship.